We are looking at 6.2 in our book. And this is a really cool method of taking everything that we've done 2D and basically making it three-dimensional. So we're going to look at example 1. So f of x equals the square root of sine of x. So that is going to look like this. Something like that. It's not perfect, but that's okay. Okay, so what we're going to do is we're going to take this. So we've learned how to find the area underneath this curve, right? From this point to this point, which is 0 and pi. So we know how to do that. What we're going to do is we're taking this and we're going to rotate it around the x-axis. So you can think of it taking something like this, taking it here, and then spinning it around this way. So we're going to get some weird oval-looking football shape from this. And so we're learning how to find the volume. We found the area here, but if we rotate it around the axis, we're going to find the volume of that shape, basically. So if you look, so this is square root of sine x for any x on this line. So if I take an x here, square root sine of x is this point here. So if I take a line here, this is basically my radius, and I can take it at any point. So if this is x2, this is x1. So this is going to be square root sine of x1 right here. Oops, that's supposed to be 1. Square root sine x2 for here. So we know that the radius is going to be this for any x value. So instead of writing f of x, we're going to write r of x. Because when we're dealing with volume, we're just going to take pi r squared, which is the volume of a sphere. So r of x is going to be square root sine of x. And again, we know that because the radius at any point in this graph is sine of x. And so when we do a 3D dimension, right, we know the radius is going to be square root sine of x. So what we're going to do here is instead of integrating f of x, we're going to add some things to it. So we're doing pi r of x squared, right? So now we can just plug in. We're going to integrate pi of square root sine of x squared. And we can just take this pi out. Because it's a constant. Pi is always a constant. It looks more like a variable than a constant, but it is a constant. It's always going to be 3.1415, etc. So it's a constant. We can pull it out. This can be simplified to pi sine of x, because the square root sign and the square sign are going to cancel each other out. Oh, also we need from 0 to pi. 0 to pi, 0 to pi, a to b. So this is kind of like our general formula. That's what it's going to look like. Of course, if we have some other shape, we're probably not going to use, actually, for now, we're just going to use this. This is our general formula. So then we can just integrate this like we have in the past, which is just, so if we need negative cosine x, 0 to pi, oops, 0 to pi. And there's, yep, okay. Negative pi cosine of pi minus negative pi cosine of 0. That's going to just give us negative pi 1 minus and a minus, so plus pi 1. I think we did something wrong.